Singer, Eternal Voice. Happy Friday, each and every one of us. So let's do science blog, particularly chemistry. Welcome to my science world. And we'll be able to go back to our last topics about expression of concentrations and of course the colligative properties, yung mga palangga. Okay, oh my gosh. So, we need to solve problems now. Or let's do the review first, a little bit of review before doing anything else. Oh my god. Shout out! Shout out to our strong and beloved president, PRRD, and our upcoming president, future president, Bongbong Marcos. Okay, let's go back to business for a while. Okay, guys, for a while, yes. Okay, so I have here problems. These problems are manageable, right? If you have studied your chemistry, especially senior high students, first year college students, particularly engineering students. Okay? So what's this about? I prepared a lot of problems to be solved. It's gonna be 35. Okay? 35 problems. Okay, but I have to pick up in random so that it will be challenging. Okay? So what's our rule? Remember our rule, our policy here in our vloggings and live streamings mga palangga. Okay, in order for us to learn properly, to practice problems, okay, to face future examinations. First, in order to expand your knowledge is to let yourself solve the problems first, okay, without referring to the original solution. Okay? And then if you get the answer, refer your answer to the real answer in the problems if you got it correctly. And then find out in what areas you are wrong and then learn by heart, something like that. And again, solve another problem, something like that. Okay? You get the points? So, muna siya kung buhaton ng matamaga. So, I need to write in the board. Okay, so the question goes like this. Okay. Okay, this one. When 25 moles of sodium phosphate. Okay, sodium phosphate. Ano ba yun? Okay. Okay. But before anything else, guys, we need to recap the formulas, huh? Recap. Okay? Like that. What are those formulas, mga palangga? Okay, we have the expression of concentration formulas. Okay. And we will be able to use this one by one if we can relate this to our problems later on. Okay. And we have the colligative properties for formulas also here. Okay. Colligative properties. Okay. So, our expression of concentrations, hindi maklaro guys. Okay, akong board. Di maklaro. Okay, like this, mga palangga. Okay, oh my gosh. Ganon. Oh, sige, klaro na siya. So, it's gonna be number one. It starts with the molarity, moles of solute over the liters of solution. Okay, like this, liters of solution. Okay. Number two, we have the normality. Okay, we have the number of equivalent. Okay. Mga palangga. Okay. Over the liters of solution. Okay. So it could also be stated as gram equivalent. So gram equivalent. So referring to the solute. Okay. You got, so the numerator part, guys, are always the solute. Okay? Get the point. The numerator is always a solute. Okay, then number 3, we have molarity. This is represented small m. Okay, this is gonna be moles of solute. Okay, moles of solute over the kilogram of solvent. So if we mean kilogram of solvent, okay, this is uh, usually 1 kilogram. But if there is a specified mass of the solution, a solvent given, then you can substitute it here, there, automatically. Okay. Number 4, we have. Okay. What's number 4? We have the parts per million. Okay. The parts per million is equal to the gram of solution. No, solute. I told you, solute is always in the numerator, right? Grams of solute times over the grams of solution, ganon. Okay, times 10 to the 6, because it's million. So this is mega. Okay, 10 raised to the power 6. Okay, number 5, we have the parts per billion. Okay, so this is gonna be grams of solute over the grams of solution, mga palangga, okay, times 10 to the 9. Okay, now, we have equivalent for the conversion also. We have the parts per million ppm is equal to, okay, mga palangga, microgram, okay, per milliliter. Okay? And then also milligram, okay, something like that, per milliliter. Okay? Milligram per liter. Okay? So note the unit well. Okay, microgram per milliliter and milligram per liter. So this is expressed in density, right? At the point. Mass is in the numerator and volume in the denominator. That is density, mass over volume. So basically, sometimes we can equate our parts per million as the density. Okay? But it's not mentioned as density, but it's just on the units that you can tell that it is also referring to the density. Get the point? Ganun. So, and this is mean parts of, for example, parts of toxic substance per million of solution. That's why ppm. Oh. Parts of toxic contaminant per millions of contaminant substance. Meaning the solution, the entire. But the contaminant is really one. For example, the contaminant is, for example, carbon dioxide, and you have air. Okay? So you will say the parts of toxic contaminant per million of toxic air. Meaning to say, the air is your equivalent as your solution, or the entire compound or component, something like that. But if you put that also to solid, okay, parts of an element over per pound per million of compound. Okay? You get the point? So here we'll adjust the terms. If you're referring to the, for example, we have air contaminant, okay, hazardous air pollutants, like I said, airborne contaminants, okay. You get the point? So the numerator is always toxic, toxic, chuba, chu, like this. Okay? The same also with parts per billion. Parts of toxic substance per billion of solution. Okay? Or per billion of, let's say, compound, per billion of mixture. If you talk about gas or air, also per billion of air. Okay, per billion of air mixture. But sometimes we will put mixture because air is already a mixture. mixture of gases composed of nitrogen gas and oxygen gas, 20% by volume of oxygen and 79% by volume of nitrogen. Okay, that is the composition of an air, plus a little bit of contaminant gases existing in our atmosphere today because we don't have a pure atmosphere already now because we have a lot of industrial gases released by oil and gas factories, companies, the exhaust gases of the cars, the vehicles, the carbon monoxide, the greenhouse gases. Okay, you get the point. So for global warming like that, so these kinds of gases will contaminate into our air, and they normally attack the molecules of the percentage of the oxygen because oxygen gas is very reactive compared to nitrogen. So what will happen now? The nitrogen will remain, and then the oxygen will react to other gases. That's why the percentage of oxygen normally will become 20.9, 20.8, 20.7, 20.6 until such time it will become deficient. It depends on the workplace and it depends on the area you are taking the, what do you call this one, the gas testing in that particular area when you do the environmental monitoring. Especially the environmentalist, the environmental engineer and the industrial hygienist will do that. Okay, the industrial hygienists will do that in their physical monitoring because it's part of physical monitoring. But the environmentalist and the environmental engineer will do that because it's part of their environmental monitoring in the air. Because environmental engineer focuses on the air, water, and the land. Okay, that's why they studied environmental chemistry as part of environmental science. So that is really their focus. Air, land, and water. And they have to test the different levels of air contaminants in air, of course. Water contaminants in water. Land contaminants also in the land. Okay, what are those? Especially those metallic substances that will be corroded due to the presence of the acid rain, okay, brought by the climate change that we face today or nowadays. This will be an acid rain and then it will decompose other elements inside the Earth's crust and there will be an interaction, chemical reaction also there. So they will also study that, the composition of the soil and the land, percentages. Usually the percentage of silicon dioxide, like that. Okay, carbonates, tuba chuchu. Carbonates mean a lot, the magnesium carbonates, the calcium carbonates, the limestone, like whatever. Okay, you get the point. We don't have to go that because our topic is not like that. Okay, now going back to the number 6, I have to erase these colligative properties first. Okay, because we still have more formulas to come, right? Okay, number 6. Okay. Number 6. This is percentage by mass. Okay, percentage by mass or mass person. It depends on you how to call that particular formula as long as it refers the same meaning or the same thing. I can say that also, percentage by mass. If you try to remove the word by, by, preposition or a conjunction in English. If you try to remove the by, you can say mass person. Okay, if you don't like percentage by mass, but it's just the same. We have also, the formula for this is percentage by mass of solute, okay, is equals to the mass of solute over the mass of the solution. Ganon. Times 100. And then number 7, we have the percentage by volume, mga palangga, or volume of solute, or volume percent. Okay, of solute. Volume of solute, okay. Mass of solution. No, it's not mass, volume, because I'm referring to volume. Okay, so like that, times 100. Number 8, we have also the most popular in chemistry because since we know in chemistry, guys, our unit of the amount of substance is the mole, M-O-L-E. Okay, blank is the unit of the amount of substance is known as the mole, M-O-L-E, and this is very popular in your stoichiometric chemical reactions, dissociation chemical reactions, chemical bonding, and so many things, okay, in general chemistry lecture. So we have percentage by mole of solute or mole percent of solute, because the moles of solute, okay, moles of solution times 100. This number 8, guys, is usually expressed in unit operations because this mass percent and volume percent are always expressed in the general chemistry lower part. You can remember in our overall material balance in unit operations, usually it's mole percent or percentage by mole. Okay? It can be also okay, but I'm talking only usually something like that. Okay? So we will not normally deal with mole percent in the general chemistry lecture, more on the volume, percentage by volume and percentage by mass. But I am, maximizing the formulas. Okay, like that. Number 9, we have the mole fraction of solute is equals to XA. Okay, X is equals to NA over NA plus NB. A and B are just hypothetical, meaning it's not really in actual or specific. It depends on the chemicals, elements, and compounds being considered in the problems. Okay, A meaning to say solute A or solute 1. B is solute B, or let's say another element, another compound like that. Only identification or nomenclature, so that we are saving the putting of letters during our solution, because it will take time also to put words every time, right? So we abbreviate in that way, or you can also simply abbreviate the letters, okay? But in some cases, letters will be the same, especially solute, solvent, and solution. The first 3 letters are just the same, S-O-L. So you cannot put X, N-A-Sol, okay? In a sol 1 is okay also. In a sol, no, not good. So this one, just why the books are always putting A and B, 1 and 2, A and B, 1 and 2. Okay? Not the abbreviation of the terms. You get the point? Okay. Numbers or letters they usually used. Okay? Any, as long as you understand what this is referring to. Okay, and then the 2 components here, A and B, or 1 and 2, guys, not limited only to 2. Because sometimes in problem solving, you have a lot of solutes, you have a lot of solvents, and to find out, so it's going to be like that, Na over Na plus Mb plus Nc plus Md. If you have 4, 4 solutes in your problem. This is only limit, minimum. Okay? Especially in the, I think in the ternary liquid extraction, I think that's unit operation, right? Like that. So 3 minimum of solvents are being mixed. So you will say Na plus Mb plus Mc. Moles of, for example, moles of ethanol, moles of water plus mole of benzene. It is also 4 quaternary immiscible liquid extraction. So you have also, for example, Na water, Mb ethanol, Nc acetone, and Md, for example, benzene or toluene, something like that. Those are usually the examples in unit operations. These solvents, really, correct me if I'm wrong. These 4: water, ethanol, acetone, toluene, and benzene. Always like this every time. Okay? You get the point? So sometimes also other will be mixed, not common. For example, a chloroform, something like that. Okay? Or let's say methyl chloroform. More of the organic liquids. Okay? Mga palangga ganun siya. Okay? And also sometimes is the steam, and then we have also the refrigerant. The refrigerants are so many numbers, and you cannot memorize that. All you have to do is to locate on the graph, on the table, something like that. The refrigerants, chemicals are applied in the refrigeration system in the fridge, in our refrigerator. That concept will be there inside. Okay, the technical theories and concepts will be studied inside the refrigeration or chilling unit or chilling equipment. It could be the AC, the air conditioning equipment. Okay, so that's why we have HVAC, heating, ventilation, and air conditioning system. It's part also with that study. Usually, really, I am really pretty sure that those are refrigerants. Okay, get the point. They are all gases in nature. They're banded together. Okay, something like that. So you need to learn refrigeration concepts, theories and principles, and also the math, how to solve it, blah blah blah. So on. So specifically the thermodynamics thing, right? Thermodynamics. Okay, gonna be like that. And number 10, we have also what else? Okay. X total is equals to XA plus XB. But normally this X total is always equal to 1. So XA plus XB is equals to 1. The same story, if you have three components, you will say XA plus XB plus XC is equals to 1, where X stands for mole fraction. Okay, ganon. Okay? O, 10 na siya. Number 11, I need to erase this one to present to you the formulas to be used. Okay? This formulas to be used, I introduce to you. This will be used in your first year college and then until fifth year college. These are what we call basic formulas and foundations. Okay? So it will just vary a lot. Not a lot. It will vary a little bit because you will now have another technique how to solve it. But actually, the algebraic way of solving is just the same of calculus way of solving. You get the point? Did you remember in your math when I was in first year college? And then I tried to solve problems in algebraic math approach. And I also tried to solve the same problem. I tried to solve that kind of problem in integral calculus approach and also in differential calculus approach, and it had the same answer. Now I come to know, so what if we will just use this basic math to solve the problem, because our only purpose is to get the correct answer, right? That's only our purpose, is to know the correct answer and to know really that certain figure or numbers or data so that it can back up to understand our theories and principles and concepts, because those are the purpose of numbers and data, to prove really that our scientific research or theories and principles are really proven true, correct, and undebatable, meaning valid. Okay, so that's why we have numbers. These are data. Okay, so these are all under your content in your scientific research. Okay, content. Okay, something like that. So before we can generalize and conclude in your conclusion part or your thesis or in your research study, something like that. Okay? So, ganun siya. Mo ang purpose sa numbers. Okay? Or data. Okay. Now, kung saan ito number 10. Number 11 na nga palangga, anak po siya. Okay? So, we have mass fraction. Number 11. Mass fraction. So, mass fraction, MF. Like this. MF is equals to MA, okay, plus MA over MA plus MB. I don't have to put 100. Put this in your brain cells. If I will say fraction, no need to put times 100. If I will say percent, you have to multiply that with 100. Because the totality is 100%, just like criteria of judging and singing competition. Voice quality, 50%. Diction, 20%. Timing, 20%. Showmanship and vocal performance, like that, 30%. A total of 100%, just like that. So if it will exceed to 100, something wrong. because that is not already a percentage theory. Okay, you get the point. So that's why we don't put times 100 here. Okay, but the story is just the same with the percentage by mass, right? Okay, and then this mass fraction. Number 12, volume fraction. Okay, like that. So volume A plus volume B. Ganon. Get the point? So, muna siya. So, our 13 is mass total. NA plus NB plus MC, so on and so forth. Our volume total is NA, no, VA, VB, VC, so on and so forth, like that only. Okay, that's formula number 13. Okay. Formula number 14. So the best way to maximize your learning how to solve math and science problems are to maximize the standard formulas in your brain cells. Okay? You need not to focus only, or you need not to limit only to this common and popular formulas. You need to expand and widen your ability to grasp and absorb other types of formulas that you may encounter in the future. Okay? Like that. So, number 14. Okay. So we have pressure. Pressure fraction. Okay. Pressure fraction is equals to PA over PA plus PB plus PC. Okay. Total pressure is equals to PA plus PB plus PC. And this is now called the Dalton's law of partial pressure. If you will just sum all the individual pressures, component A, component B, component C, and these are called partial pressures. So the total of all partial pressures of the components will be equal to the total pressure, okay, of your entire system considered, or entire solution considered, or entire mixture considered. Okay? So that is Dalton's law of partial pressure. Here. Okay? Dalton's law of partial pressure. Get the point, mga palangga? Like that. Now, Dalton's, you will confuse also, oh my gosh, Dalton have two major contributions in science. The other one is studying the atomic theory. Okay, John Dalton atomic theory is also the contribution in science for Mr. John Dalton. And also this one, partial pressure. So don't be confused in the in the examination in the future. This John Dalton have two contributions in science or in chemistry. Okay? First is the John Dalton atomic theory. The second is John Dalton's law of partial pressure. You get the point? That's very clear. Okay, so we have now 14. 14 formulas for the expression and of the concentrations. The other thing, guys, is already, shall we say, dimensional analysis conversion way of solving. So your first technique, let's put that as number 15. Okay, your first technique, guys, is you have the basis of calculation. Okay, basis of calculation. This data is mentioned in the problem. Okay, you get the point. Now, normally, in expression of concentrations, there could either be mass, always put this in your brain cells, mass, volume, moles, pressure, and temperature. These five quantities all the time. Correct me if I'm wrong. Three of these quantities will always be present. Why? Because these are highly measurable or quantifiable through numbers or through data, because these are all extrinsic property, an extensive property of the mixture of the solution. So we can quantify this or measure. Okay? So it's either temperature, pressure, like that, mass, volume, number of moles. Some of them also will lose a little bit. Okay, but then come again another problem. And then some of the intrinsic property will also come, like density. Okay? Like density, boiling point, freezing point. Okay, just like in colligative properties. Okay? Point something are more on the or more on the intrinsic property. Okay? Meaning it doesn't depend on the size of the system and the amount of the particular container considered or the amount of matter present or let's say the sample size of your system. It doesn't depend on that. Okay? You get the point? Okay, that's it. Okay, 14, 15. Okay, you will start with the basis of calculation and then normally guys, you need to multiply that to chuba chuchu. Chuba chuchu meaning to say if you need a molecular weight, molar mass, you multiply that with the let's say molar mass, molecular weight, and then try to manage which can be cancelled so that you can reverse the molecular weight before multiplying so that you can cancel the unit. And then, but then, in step 3, use the stoichiometric relationship referred to the balanced stoichiometric number of moles. Okay? In your equation. You get the point. I said number of moles, not the number of atoms. Okay? You get the point? Muna siya may tabo. Okay? If you consider the number of atoms, problem. For example, if I have 2 moles of water, 2 moles of water. So, if you use atoms, this is 4 atoms. Okay, 4 atoms of hydrogen and 2 atoms of oxygen. But this is only 2 moles of water. So use the 2 moles of water rather than breaking that apart so that it will become wrong. Because we are not interested in the atoms. We are interested only in atoms if we balance the chemical reaction. You get the difference already. We only need the atoms to balance the chemical reaction. We need the number of moles to compute the stoichiometric relationship of the amounts being asked in that particular problem. So after that, you can say gram to mole, and then going to, let's say, heat. Okay, or heat going to mass, going to gram. You should picture out also the flow, FLOW. You need also to flow up. To have a flow chart in your brain cells. You can write or not because it's really easy, right? You can only picture up in your imagination. This is from gram to mole. These techniques will be helpful for you to pass certain examinations, okay, in the future, especially math, okay, or science problems. You will have a clear perspective what's going on to the kind of formula you use, and you will have a direction, okay. Where this particular formula lead you to get the desired destination. Just like driving a car, where is your destination really is? So solving a problem is also just like that. Okay? So, say grams to mole and going to heat. Heat going to mass, going to volume. And then somewhere along the mass, you can relate with the molecular weight and molecular mass. And somewhere along the volume, you can relate that with the density. So, ipasok din sa inyong brain cells, ano din na siya sa Sotero? Yes. In stoichiometric chemical calculations, usually like that. First, I am telling you the longhand way of dimensional analysis of conversion way of how to solve the problems. I'm saying to you right now that we will be able to use the standard formulas. Standard formulas will be there always, but sometimes also we need to use this kind of approach. Now we have the basis of calculation times the molecular weight, something like that. And number 3, we need to use the stoichiometric relationship, the number of moles, and bingo, we can reach to our desired point. But in the problems, you will analyze always, guys, that the volume is always linked to the density. Okay, no. The volume is always linked to the density. The mass is always linked with the molecular weight, the molar mass, or the molecular mass. Okay? So that's will be our basis so that we can multiply it there, so that we can reach to our destination. Okay, so if you are not really that strong in this conversion way of solving, then do not go for that. Go for the standard formulas. For me, when I was in college, I mixed it. Sometimes I like this, dimensional analysis because it's easy for me to manipulate. And sometimes also I use this standard formulas because it's already, engraved in my brain cells. But sometimes, due to memory fails, sometimes really it happens. I rumbled the quantities, then I cannot use that anymore. Maybe I will become wrong. And then I will change to the other way, the conversion way of solving. This will be applied in usually in expression of concentration in computation of the molarity, normality, molality, the grams, the mass, because it doesn't have to focus on the standard formula. Okay, enough to use the conversion way of solving. Okay, if you like, inconvenient. Okay, because some also cannot use this well, and me also are not comfortable. I'm just telling you, sometimes I will use this. Okay, meaning 50-50. It depends on the type of questions I will be able to face. Something like that. Okay? Ganon. Okay, and you will mix the science, theories, principle, concepts, foundations with math, numbers. Okay, always like that in engineering. You get the point? So, yan, yourself about numbers. Okay, kay mga multi ka. Pero it doesn't mean if you are not good in math, you cannot manage to pass engineering, subjects or curriculum. Okay? You get the point? So, effort language siya. Okay? Then ganon. So, our first example for today is charot. So, what's this? I will read first, mga palangga, and get a blank sheet of paper. Okay. So, 0.25 moles of sodium phosphate added to 200 milliliters of solution. What is the concentration of sodium ion in that solution? Wow, ganon. A, 3.75 molarity. Okay. B, 2.50 molarity. Okay. C, 3.10 molarity, D, 0.80 molar, E, none of the above. Okay, how can we solve this? Okay, like this. Okay, I will write the problems on the board. It looks like easy, but you need to think, right? So, number one, when 25 moles, so the moles are present here, 25 moles like that of sodium phosphate like that. And before anything else, guys, when you have different problems mixed na siya talaga, this is the confusing part and tricky part of the examination because it will be rumble. The best way to remember is to take note the main topic involved. Okay? And you get it exactly, the terminologies. For example, it talks about more on concentration, then that's basically expression of the concentration, like that, things like that. But sometimes also, due to not mentioning really, and you'll be the one to decide what's this all about, and you will just feel it by yourself. That's the difficult part, really. Okay, in most cases, it's the difficult part. If not, all will become top-notchers. Right? If there's no issues like that. If there's an issues that only will top, 10 only will top, and a lot will fail, let's say half will fail out of 700, 300 will fail, that means it needs really an analysis to solve the problem. Okay? It's not just really direct substitution by common sense, right? You get the point. So, like that, so sodium phosphate. Okay, mga palangga. Okay, added to 200 ml of solution. Ganon. Diba? Of solution. Okay. What is the concentration? Okay, what is the concentration of sodium ion? Chararat. Sodium ion. Okay, in that solution. Ganon. Okay, mga palangga. Okay. So, it's easy to understand, right? Okay? So, it's gonna be like that. Okay. Our first objective is to get the concentration of sodium ion. So, that's our required. Okay. Concentration of sodium. And then that is too general. Concentration, there's a lot. It could be molarity, normality, but take note of the unit. expressed. Since that is molarity ba? Yes. No, it's not really mentioned in the problem. You can only look at the choices. Things like this, huh? Okay, the choices are expressed in molarity, then solved by molarity. Things also like this, okay? You get the point? Because it's general here. Oh, what is the concentration of sodium? And there's a lot of types of concentration. So you will wonder, oh, what's this one about? And you will waste your time so many concentration formulas to use. And now look at the choices. It's expressed in moles per liter or the molar. Then use the molarity. Okay, something like that. So required molarity or M, right, of sodium ion. So I will put M for sodium ion. So let's say Na positive. Or I will say, if I cannot write Na positive, I could also put the bracket of the sodium ion because the bracket means the concentration. Okay, you get the point? So 2, you will choose 2 in this way. It depends on you, your convenience and comfortability or your comfort. Okay, something like that. And then it's going to be molarity is being asked here. Then we need to remember the formula of molarity. It's going to be moles of solute. We need to say the moles of sodium ion. Because you're asking of the sodium ion. This is the tricky part. Because me also in the past, in my 20 years ago in chemical engineering, okay, sometimes I am also confused. I will directly use the sodium phosphate. But take note, though this is a solution already, okay, sodium phosphate plus water is your solution. And then you can interpret that your solute is sodium phosphate. Take note really the difference, guys, okay? I say molarity, okay? The definition of the molarity is moles of solute per liters of solution. Now, in your problem, the only solute here is the sodium phosphate, no other thing, right? And it's very clear. Okay, you will put that, of course, in the first place due to the definition and of the formula, because it says moles of solute, okay, over liters of solution. If you just depend every time in the formula, no thinking far. Okay, if you think critically, the problem asks the sodium ion. So it will change now your definition to something new, but still the same as solute. It could be a component, elemental component, or a solute generally. So we can say this is now the moles of sodium ion, not the sodium phosphate. Okay, sodium phosphate is your solute, but the sodium positive is part of your solute but exists as a cation. There's a positive charge at the top of the sodium. That's very clear. Do I explain it clearly or not? So this is sodium ion or sodium cation with a charge of positive 1. You don't have to put this sodium phosphate anymore, because you will be wrong when you solve that in that way, dependent only on the definition of this original formula. Sometimes it varies, as I told you. Then terminology is very important, terminology. Okay, like that. So moles of sodium positive 1 will be now equal liters of solution. Ganon. Like that. Okay. Now still you are finding this moles of sodium positive 1 you don't know. Ikis. Ganon. Molarity, ikis. Ganon. So you have only one check, I think, liters of solution. Check comprehension with your problem. Go back to the problem if you have the value of the liters of solution. Okay? Blah, 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 so and so, ganon, di ba? Okay? So review it. Okay? Like this.